Hello everyone, welcome to my channel, and I think we have a new circuit here. We have here the transistor, LED blue and some resistor. Also here we got a LED, transistor, some resistor. Also here we got the LED, two transistor and some resistors here. And we got three circuits here. Let's see the circuits of each one. This one, two transistor, and this one, also this one. Let us see the circuit of each. We have three circuits here. The circuit of this blue LED is this transistor circuit PNP, and this is our previous circuit. Current flows here when you close the switch to the emitter, to the transistor, to the collector, that is PNP. Also current flows here to the base and to the base resistor, transistor to the base resistor. That is the operation of the PNP, and we calculated all the values here since this is our previous circuit. We have some parts here, and we have pin out, also the given data, and that is the circuit we have here. And we have now this circuit, the red LED, and the circuit of that is transistor circuit design, and that is NPN. When you close the switch, current flows it here and also to the base, conducting a transistor in saturation mode. And since this is our also previous circuit, we calculated all the values here, or some configuration, and then that is our circuit design for that. And we got now here our new circuits here, and it has two transistor here, lots of resistor, and a yellow LED. And the circuit of that is this Transistor Sziklai circuit. It is the combination of these two previous circuit, NPN and this PNP. That is the combination of the two circuits to make this Sziklai or Sziklai transistor circuit. We got this BC557C PNP, and we have BC547C NPN. Base resistor, LED resistor protector, and voltage supply of 5 volts. We have given here voltage rating of the diode, current rating, and also some values given in the data sheet of the transistor. Also we have here the pin out of the two transistor. So this is a Sziklai or Sziklai transistor circuit, and we're going to compute the values of RD here to protect the LED, and also base resistor here to protect the transistor, also base resistor here to protect the transistor here. Two transistors connected in this fashion. Let us trace the current flow here. When you close the switch, current flows here to the LED transistor to the ground. Current flows also here to the transistor, to the base, and to the ground. Also flows here, transistor, base to the ground. We get three loops here. So let us find the value of each resistor here in order that our transistor is conducting in saturation mode. So it means we need to pass this load in here, switching the transistor in saturation mode using these two transistors. Finding RD here using Kirchhoff's voltage law here. We get here voltage supply minus voltage drop across the resistor, the diode, and the collector voltage collector to emitter of Q2. BCE saturation is, where is that? BCE Q2. So it's not in here, 0.02. So we get here voltage drop across the diode, supply voltage BCE Q2. 0.2, we get 2.8 volts voltage drop across RD, and we go using Ohm's law here, and the current of the resistor is also the current equal to the current of the LED here, and that is given in the data sheet, which is 0.02. They are in series, so current in series is equal the same with the LED, and we get this 140 ohms. I use 220 ohms. So let us compute for the current gain of Q2. Since this is Q2, current gain HFP is equal to IC over IB. We know collector current here is the same as the current at the resistor and LED, 0.02. We get here 0.02 divided by 400, the HFP of Q2, or this 547C. And we get now the base current of 0.005 ampere. And we're going to find the voltage drop across this RB2. So in order to find the voltage drop here, to know when the transistor is turning up, just to turn on the transistor, we need to find the voltage drop across here. Current flows here, in here, up to here only, base to emitter, just to turn on the transistor. And we got here the voltage supply minus BCE saturation of Q1. This is Q1 given here, Q1 negative. So 5 minus BC of Q1 is negative 0.25 volts. This is PNP, that's why it has a negative CE. We get now 5.25 volts. Using Ohm's law, we find that this is already computed here, and the base current here is computed also here, and we get this resistor value of 105,000 ohms, and I use 105 kilo ohms. That is the same. So let us find now the voltage drop across RB1. Since because the current flows here, we close the switch to the BE, EB, and to the resistor. Voltage supply minus the BE SAT. Voltage supply minus the BE SAT, or EB, BE SAT. And voltage drop across here. So we got this. Voltage at RB1 is 6 volts. Did you see that? Voltage supply minus BE SAT. Voltage supply minus BE SAT is negative. That is given in the datasheet. Negative 0.7. That is negative 0.77, and it is given datasheet. And we got 5 plus 1, because negative plus become 5 plus 1. Voltage drop is 6 volts. 6 volts is voltage drop here. So we got now this voltage drop here. Let's find the current gain using IC over IB. Since this is PNP, also we use the same current gain formula here, IC over IB. And we know that collector current here is the same as the IE. And we get this 0.005. And as we have seen here, collector current and current at the emitter of PNP is the same as the base current of this NPN, since they are connected from collector to base. So we use that current, this one, 0.005, that is IC, equal to the base current of this transistor. We get that HFE of this transistor given in the data sheet, and we get now the value of 0.00006167, 6 zeros. Ohm's law, we know that the voltage drop across RB1, where is that? RB1 is 6 volts. And then we get the current at RB1. We know that from here, which is IB1, RB1, divided, we got 35 mega ohms. Very big value of resistance. Resistor in the base of the PNP, 35 mega ohms. So I'm using 35 mega ohms here, and the circuit is working. This yellow one. So this is our circuit, and this is now our final circuit here. Circuit diagram. And we get here the layout. We have 5 resistors here, 5 resistors on transistor here, and that is transistor Q2. And we get 3 resistors here, 2 resistors, transistor again, transistor, 3 resistors, and LED yellow. So that this are the parts. And these are the layout. That is a combination of lots of resistor to make it 35 mega ohms. See this, Q2, Q1, that is Q2 here, Q1, and this is the layout. So we got now 3 circuits here. The combination of PNP and NPN, making it a transistor Sziklai circuit, and it is functioning and it is working. So we got this new circuit, transistor Sziklai circuit, using our computation here, and I think the circuit is good, nice, and functioning, using the 2 transistor PNP and NPN, making it a transistor Sziklai. And this is the actual circuit of the transistor Sziklai, or Sziklai. This is NPN and this is PNP. 2 transistor combination to make it a transistor Sziklai, and the circuit is working. And thank you for watching the video, and